ladies and gentlemen, we're going to start graphing some polynomials, but will you notice the production value? Can you look at the green screen? It's amazing. I can't. Okay, let's actually do some work here. So we're going to graph some polynomials, and it says identify end behavior, x-intercepts, and then we'll describe the end behavior using limit notation. So the first thing we're going to do is just understand that since this is a positive leading coefficient, and it is an odd degree polynomial. Remember, the highest degree in the polynomial is the degree of the polynomial. So since this highest degree is 3, this is a positive leading coefficient in an odd degree polynomial. So positive odd, as you read left to right, is increasing. It's going to look something like that. So I know the graph is going to look something like that. What I want to know is, where does this thing hit the x-axis? That's the main thing we're looking for. So to find the zeros where it hits the x-axis, we're going to factor. So I'll first factor out the GCF, which is x, and then I have x squared minus x minus 6. I like how that's different color. There we go, red. And then I'm going to factor this, so I'll find numbers that multiply to -6 and add to -1. That'd be x minus 3, x plus 2, and then we still have x out front. So remember, this is a 1x squared, so you can kind of do it quickly. I want to know where these equal 0. So the 3 x-intercepts would be at x equals 0. Because if you set x equal to 0, then 0 times everything will be 0. Anytime you factor out a GCF of x, then 0 will be a 0. Again, if you plug in 0 in this, all of it goes away. So if you factor out an x, then 0 is a 0. The other ones would be at 3 or -2. So on my x-axis, first thing I'm going to do is put my x-intercepts at -2, 0, and positive 1, 2, 3. And then we're going to see if we can kind of map this thing out. And we're going to learn some more things about graphing them, but right now, let's just kind of say, look, I know that it has to start down here, and I know that it has to end down here. So how can I draw this so that it'll pass through those zeros? And the way it's going to work is, we're going to go up, and you're like, okay, I'm going to pass through the x-axis, and then I'm going to pass through the x-axis, and I'm going to pass through the x-axis. Now, I don't know about like where these maxes and mins are, but it doesn't really matter. That's not what we're trying to do right now. We're just trying to describe the end behavior and the x-axis behavior. So since it's passing through 3 times, I drew it and it works okay. Now we're going to describe the end behavior using limit notation. So when you're doing limit notation, first realize that when it says x goes to infinity, we're going to say infinity. That's describing it to the right. So we're saying as you go to the right, as x goes to infinity, what does the limit of the function do? What does y do? So as you go to the right, the function goes up. So we'll say y goes to positive infinity. And as x goes to the left, as x goes to negative infinity, as you go to the left, so as that's left, y goes down. So we'll say y goes to negative infinity. So using limit notation here, we have our end behavior, and by factoring, we found our zeros. Okay, let's try another one. This one is also positive odd. It's a leading coefficient of 1 and is degree odd, so it's also going to look something like that. To find the zeros, I'm going to factor. This has got 4 terms, so we'll factor by grouping. So the GCF between the first 2 terms is x squared, and you have x minus 2. Bring down the minus sign. The GCF between 4 and 8 is 4, and it'll be x minus 2. Remember, it's minus 2 because you factored out the -4. So -4 times -2 is positive. Then I have x squared minus 4 and x minus 2, which, hey look, that's dots. X plus 2, x minus 2, x minus 2. So I'm going to write this a little differently, and you're going to see there's a trick going on here. X minus 2 quantity squared. So we have zeros at -2 and at positive 2. So -2 and positive 2, right there, right there. And I know the end behavior is supposed to look like this, but it's a little trickier because there's going to have to be 2 turnaround points. But the thing is, I can't really draw 2 turnaround points because I get stuck. If I draw a turnaround point here, then I would have to hit the x-axis again somewhere, which I don't have another 0, so I don't hit the x-axis again. So what's tricky about this one, and I'm going to talk more about this in a second, is this is a degree 2 multiplicity. See how it's the same thing twice? So what that means is at that 0 at x equals 2, instead of passing through the x-axis, it's actually going to bounce off. So when I draw it, I'm going to start down here. It's going to go through, and then it's going to turn around, and because this is an even degree multiplicity, it's going to bounce off. Describe the end behavior the same thing. As you go to the right, as x goes to infinity, the function goes up, so y goes to infinity. And as you go to the left, as x goes left, y goes down, so that's negative infinity. Let's do one more. Okay, so this is degree 4, and it is a negative leading coefficient, so this will be kind of like your m sort of polynomial. Let's do GCF first. Let's do x squared. I'm actually going to factor out a negative 2, though, because I don't like having a negative out front. So I'm going to factor out a negative x squared, and then I will have positive 2x squared plus x, and then minus 3. Is that right? Negative 2x to the 4th minus x cubed plus 3x squared. There you go. So now I have a polynomial I can factor. Let's see. I could probably just guess and check this thing. Let's see. 2x and x. You can always split the middle. So I need numbers to multiply to negative 6 and add to positive 1. What adds to negative 6 and adds to positive 1? I got one. Negative 2 and positive 3. So let's do this. 2x, so we get negative 2 on the outside, positive 3. There we go. So 2x plus 3, x minus 1. That means my zeros are at, remember, you factor out an x, so 0 will be a 0. This would be if you subtract 3 and divide by 2, negative 3 halves, or at positive 1. So 0, negative 1.5, these are all kind of together, positive 1. So how am I going to draw this thing so that it does one of these deals? Well, because it's got to go up and it's got to end down. So this is the same thing I was saying before, and what we're going to talk about in a minute more is these multiplicities. Since this is an x squared, at 0, it's not going to pass through, it's going to bounce off. So when I draw this, I'm going to say it goes down, it passes through at negative 1.5, and then it turns around, but instead of passing through right now, it's going to bounce off the x-axis, and I'm just going to say it turns around and then goes back down now. So it's kind of an M, but if you look, it's a little tricky because it bounces off at 0 instead of passing through, and that's because this is an even degree multiplicity. So our end behavior here is x goes to the right. As x goes to infinity, the function goes down to negative infinity, and as x goes to the left, negative infinity, the function also goes down. So the limits of both ends are negative infinity. So let's go back and talk about the multiplicities that I was saying. When we say a 0 is a multiplicity of different degrees, if it is an odd, if you have an odd degree multiplicity, then what's going to happen is you're going to pass through the x-axis at that point. You're going to pass through the x-axis. If it is an even degree, then the function is going to bounce off the x-axis at that 0. So we're going to draw a couple of these that are already in factored form, and maybe this will help you see it. But the main thing you want to remember is that if you have an odd degree multiplicity, so that's the degree of the factor, if the degree of the factor is odd, then at that 0 it's going to pass through, and if at that degree is an even multiplicity, then it's going to bounce off the x-axis. Let me show you a couple. So we have zeros. These are already in factored form. We have zeros at 0, at 2, and at negative 1. Now we need to know what the degree of the whole polynomial is, and since this is in factored form, we're going to just add up the exponents. So 4 plus 3 plus 2, this is a degree 9 polynomial. If you were to expand it all out, you would end up with an x to the 9th at the beginning. I have no interest in doing that, but it is a thing that you could do. So this is a degree 9 polynomial, and since it's a positive 1 in the front, you'll notice that none of these have a coefficient that's negative. Then it is a positive leading coefficient, and it is a degree 9 polynomial. So it's odd, positive, that means it's going to look like this. Okay, so I know as I read left to right, it's increasing because it's positive and odd. Now let's put our zeros at 0, negative 1, and 2, and then we'll see if we can map it out. So at 0, we're going to bounce. That's going to be a bounce. And at negative 1, that's also going to be a bounce. But because these are even degree exponents, so it's going to bounce off the x-axis at those 2 points. But 3 is odd, so it's going to pass through at the 0, x equals 2. So at x equals 2, it's going to pass through. The other 2 it's going to bounce off of. So I'm going to try and do this as I go left to right. So start down here. I know it's supposed to look like this, kind of. But I'm going to go left to right. So my first 0 is at negative 1, and you're like, negative 1. All right, that is an even degree multiplicity. Negative 1 has an exponent that is even, so it bounces off. So it goes up to negative 1, and then it turns around. It bounces off the x-axis. Now we know we got to go back for more. So So what's our next 0? In order, we go from -1 to 0, which also even degree multiplicity. So it's going to go back up to the x-axis and try and get through, and no, it gets stuffed again, so it turns around again. Bounce off the x-axis. Then we go to +2, that's right here. That 0 is +2, and it's an odd degree. So this time it's going to go up to the x-axis, and finally it's going to bust through because it bounces through, or it passes through the odds, bounces off the even. So it passes through at +2, and that gives us the end behavior that we needed, but it had to go through those x-axis in a specific way. Let's try another one. This one is degree. You got to add up the exponents. 3, 4, 5, and then don't forget that's a 1. So 6. So degree 6, and since it's all positive coefficients, the leading coefficient will be positive as well. So it's even and positive. That means it makes a W, kind of, some shape kind of like that. So let's try it now. Where are my zeros? My zeros are at 1, 6, and 0. So 0, 1, and 6. 2, 3, 4, 5, 6 right there. Okay. So since it's supposed to be a W, I know I'm going to start up here, and I'm going to end up here. But as I go left to right, I'm going to start up here, and I'm going to say, all right, my first 0 that I'm going to hit is going to be at x equals 0. That is an odd degree multiplicity, so it's going to pass through. Oops, that's kind of weird. So it's passing through here. Then it's going to turn around, and then we'll see what happens. At 1, that is also, or no, this one is an even degree multiplicity. So at 1, we have a degree 2, so this is an even multiplicity. So when it goes up to hit that 0, it's going to bounce off. Now it's bouncing off from below, so it bounces off and it turns back around. Now the last time, I think it has to pass through because it's got to end up there. It's going to pass through, and let's see. At 6, it is a odd degree multiplicity, so it will pass through. So it does look the way I hoped it would look, as long as I follow the x-axis behavior appropriately. And then let's do maybe one more. Let's see if we can create a polynomial that would kind of look like this. So if you have a 0 at -2, +1, and 5, then my factors would be x plus 2, x minus 1, and x minus 5. But if you just left it alone, that's a degree 3. 1, 2, 3. That's a degree 3 polynomial, which means it would look like this. But this that I'm dealing with is not a degree 3 polynomial because I know the endpoints both point up. So if they both go up, that's a positive even graph. So I need this to be an even degree. So I need to give one of these guys a 2. I need to square one of these factors so that it becomes degree 4. And you can't really just do it randomly. You need to make sure you pick the one that bounces off the x-axis. So you can see at -2, that was odd, it passed through. But then at 1, it bounces off, which means I need this 0 to be an even degree multiplicity, so I'm going to make that a squared. And now what will happen is when I get to 1, since it's even, it'll bounce off. And then the last thing at 5, that's odd, so it'll pass through. So that is now a degree 4 polynomial that will bounce off, like I said. Now, we can kind of keep playing this game and generate a bunch of different ones, but I'm going to see if I can make one now that's a degree 8 polynomial. So the zeros don't change. All that's going to change are the degrees. I need them to add up to 8. But this one has to be even. So let's just try, well, let's make something up. How about we do 4, and then you're like, all right, that's degree 4. Now this is 5, 6, so what if I do like that? Does that work? 1, 2, 3, and then 4 more makes 7, and now it's degree 8. It bounces off at 1 because it's even, and then these are both odd. So that'll do it. You could probably do the same thing and just flip those. Make this 1, and then make that one 3. As long as these are odd, because those are pass-throughs, see those pass through, and as long as this one is even, that's a bounce off. So you could do this probably other ways. You could probably make the middle a 2 and then do like 3 and 1 and 3. I don't know. There's probably other ways I could do it too. But the main thing is the middle one at x equals 1. It's a bounce through, so that's or bounce off. So that's got to be an even degree. The others have to be odd. Now this is a trick. It says write one that's in degree 9. I can't do that because degree 9 is always going to look something like that, or I suppose I can make it look like that. But the point is, if it's an odd degree, the endpoints are going to go in different directions. So it's like up, down, I can't really do it on the screen, up, down, or like that. So they're going to go in opposite ways. These both go up, so it's even. I can't do this. This is a trick question, so this is impossible. You can't do that. So you've got some practice problems to work on. Go ahead and try those, and make sure you get your math labs done. And while you're at it, why don't you